Okay, now we are going to see yesterday we have seen some concepts called what is refraction. Okay, now let me fastly in the last class we have seen what is refraction. Let me fastly uh, reiterate and let me uh, tell about what is refraction again. So see now, refraction, right? For refraction, I have told yesterday in the class that it is the bending of light. It is a bending of light. Whenever light encounters with the interface of a surface, if this is the light which is falling at the interface, let me say this is my incident light. After falling at the surface, let this be the interface of that particular mediums, medium 1 and medium 2. If this is medium 1 and this is medium 2, then at the interface of this two medium, there is some at the middle of this two media, there is one interface. If the light encounters at the interface, after encountering that interface, it bends somewhat. It bends like this. It can see here, it can bend like this. If it is bending towards this normal, this line is called as a normal. If it is bending towards normal, we say that this medium 1 is a rarer medium and medium 2 is a denser medium, right? That is the first case. If the light, instead of bending towards normal, if the light is going like this, means it is going away from the normal. If it is going away from the normal, we can say that then the medium 1 will be denser medium and medium 2 will be rarer medium. This is what we have seen in the previous class about what is meant by refraction. This is a definition of the refraction. Now, refraction is what? Refraction is a bending of the light whenever it is passing from one media to another medium, right? So now we can say that this refraction, the bending is mainly caused. Why is the bending caused? The bending is mainly caused due to what? Due to densities of the media. There are two media. If the density is, there is a difference in the density, that difference in the density causes the light to bend. Is it okay, ma'am? So now the bending of the light is happening mainly because of the differences in the densities. If there is a difference in the density between the two media, then that difference in the density of the two media will cause a bending of the light. Okay, the next one. Here, the next one, my question, let me say one example. It is refraction in nature. Refraction in nature. Can you hear this one? Can you see this one?
Yes, sir.
So, Sienna,
Yes,
refraction in nature. Let me see one refraction in nature example. Let me say one example regarding what does that example means. My question is, why do the stars twinkle? The twinkling of the stars happens because of what? If I say that the twinkling of the stars is mainly because of what, ma? It's a refraction.
Light.
It's a refraction, right? See, no. Let me say like this. Initially, when you see the star, it appears from the space. It appears like just one small ball, which is a shining ball. It appears like a shining ball. Now, when it comes into the atmosphere, when I see it from the up to here, it is from the space. This is from the space. It is in the atmosphere. In the atmosphere, when I see the star in the atmosphere, it looks like this. Something like what to say? There is some kind of emerging kind of light from the star. Okay, when it comes to the surface to the earth surface, when we see at the earth surface, here in the earth surface, it looks like what to say, let me draw the star. It looks like the star. It looks everywhere. It will be like what to say. If this is dot, it looks like the star kind of thing from the Earth's surface. Okay. So this mainly happens what because of the refraction of the light. So listen now carefully. Where does that refraction happens? The refraction of the light happens here in the atmosphere. Whenever it comes to the atmosphere, in the atmosphere, you can see that the refraction of light takes place. The refraction of light takes place in the atmosphere, and that too, refraction of light takes place in the atmosphere. In atmosphere, has this light passes through the atmosphere, and also due to turbulence nature of the atmosphere. Turbulence nature. What is meant by turbulence nature of atmosphere? In the atmosphere, we can see there are many different kinds of constituents. In the atmosphere, we can see there will be wind, there will be light, there will be many different constituents, contents of that atmosphere. Now, in the atmosphere, what happens due to the velocity difference in the velocity, difference in the speed of this wind, speed of the what is that light, and all this kind of things, this refraction takes place. That is what we call as a turbulence. Turbulence is nothing else but it is the phenomenon which happens in the atmosphere mainly because of the what to say uh, how fastly a light can move in the atmosphere and how fastly a wind is blowing the atmosphere. All these things denotes to the turbulence. Or else, if I want to tell it technically, it is regarding the flow of wind. It is regarding the flow of wind, and it is also regarding the velocity of the wind or light at any some particular point. If you are talking about some particular point, it can be flow of wind through that particular point, or it can be flow of velocity due to that particular point. Whenever it passing through that particular point, if light is passing, let me say in the atmosphere there is one particular point. If light is passing through this particular point, or if the wind is passing through this particular point, every time the same amount of light will not be passing through that point. Every time the same amount of light will not be passing through that point. Means what is actually happening? There is some irregularity of light flowing through that point, or there is some irregularity of wind passing through that point. So this kind of fluctuations creates this turbulences. Have you understood what is turbulence now? Is it clear? Okay, so
Yes,
that is
sir.
called as a turbulence. Now, let me say one more thing about atmosphere. I have told this refraction. Where does the refraction happens in the sky? It happens in the atmosphere, right? Refraction happens in the atmosphere. Excuse me. I hope you understood, right? What is meant by turbulence? Is it clear, ma'am?
Yes, sir.
Okay.
Yes, sir.
So this is about the turbulence. Turbulence. So this refraction happens in the atmosphere. Because of that refraction only, the star twinkles. Okay, the twinkling of the star is mainly because of the refraction. Now you see now the twinkling effect. So we can say that now here the twinkling effect of the star due to the atmosphere refraction. So we can say here now that star is going to twinkle only because of the atmospheric refraction. So from this one, what we can say that from here we can also say that the starlight undergoes. What are the light here? We have written right here. We have drawn here right. The starlight, this particular starlight will undergo. The starlight will undergo several refractions while reaching the Earth. This atmospheric refraction occurs in the medium of gradually changing the refractive index, right? Whenever the refractive index is changing, then definitely the refraction also changes. So we can say that if I look a star from the space, it looks like a shining ball. When it comes to the atmosphere, there will be some like a atmosphere. Due to the atmospheric refraction, the starlight will undergo the refraction. That is what? Refraction of light in the atmosphere. And it happens due to what? It happens due to the turbulence nature of the atmosphere. Turbulence nature of the atmosphere. But when it comes to the Earth's surface, it looks like this. The star as it appears from the Earth surface is this one. From the space it appears like this. From the atmosphere it appears like this. From the Earth surface it appears like this. After undergoing the refraction, it appears like this from the Earth. Is it clear?
Yes, sir.
Yeah.
Yes.
Now we have seen about loss of refraction. There are two laws of refraction, right?
Yes, sir.
First one. What is the first one? First law is what? Refracted ray, normal, and the other one is what? Incident ray.
Incident.
Refracted ray, normal, and the incident ray. All right. We can say in this way: the incident ray, refracted ray, and the normal at the interface of two media. At the interface of two media. Interface of two media lie on the same plane, right? This is the first law. All this refracted ray, normal, incident ray, all this at the interface. Interface means what? We are talking about this one. If this is my incident ray, and again this refracted ray, right? Incident ray, refracted ray, and the normal. We are talking only at this point. We are not talking about the in the media. We are talking at this point. At this point, see, this is your incident ray. This is your refracted ray, and this is a normal. All this three at the interface lying on the same plane or not?
Yes, sir.
Yes.
They are lying at the same plane. Okay, then the second one. What is the second one? Second law, we have seen that the ratio of sine of the angle of incidence, sine of the angle of incidence to the sine of the angle of refraction is what, ma? Is
Constant.
constant. This is the first word, second law, right? So we have written sine of I is equal to sine of R equal to constant. So this is most important laws. These two are most important laws. And this is about the laws of refraction. Then next we have seen about refractive index. Refractive index. We have seen about refractive index means what I told. Refractive index is about what to say. It talks about how fast a light travels through the material, right? Refractive index means what? We are talking about how fastly a light will travel from one material to another material. So we can simply, I can say that it describes about how fastly light travels through a material. Material means what? Through one material to another material. It means this, see now, we are having two media here, medium 1 and medium 2. Now, if light is to be passed from one medium, and after that it goes in this way, right? This is the first medium. How fastly light is going from medium 1 to medium 2, that is called as a refractive index. And the important one I'm writing here, now you can note it down. Points. First point. Refractive index is dimensionless. This is the first one. Means I can say it is a unitless. It doesn't have any kind of units. Refractive index is what? It's a dimensionless. Is it okay?
Yes, sir.
It is a dimensionless. Why it is dimensionless? Because we know that what is that refractive index? First of all, refractive index is denoted by small n. Okay, it is denoted by small n. Now, if it is that is the case, we can say that it is small n is equal to, we have written in the previous class, it is speed of the light by speed of the light in vacuum by speed of the light in medium. This is a formula for the refractive index. We have written yesterday in the previous class. What is that one? It is speed of light in air or vacuum divided by speed of light in, what is that? Medium. So refractive index formula we have written, that is speed of light in air or vacuum divided by speed of light in medium. And refractive index is denoted by small n or neta, that is equal to C by V. Have you written this one? Have completed?
No, sir.
Make it fastly.
Yes.
Can you understand my writing here?
Yes, sir.
Yes, sir.
Completed, sir.
Everyone have completed?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah, fine. Now, refraction of light. These are the examples. This may be asked in the exams. Refraction of light in real life. Refraction of light in real life. First one I can say, I hope you all know the mirage. Mirages.
Yes, sir.
Or else we can say it is also called as looming. Mirages, it is an optical illusion actually. It's an optical illusion, right? It looks like CNO. If you are going, especially it happens in the summer days. If you are going on going anywhere, we can see on the far distance, we could see something like there is some water. But when we go near to that one, there will be no water.
Yes.
See, it's an optical illusion. What to say? Resulting in the resulting from refraction of light. Okay, refraction of light. Right. The next one I can say, even the rainbow is a refraction of light. I can say that formation of rainbow. Formation of rainbow. I can say it's an example of what is that? Refraction. How it is an example of refraction? CNO. Whenever the light falls upon the water drop, the bending of the light takes place in the water drop, and that bending of the light will causes the whip jar of that particular whip jar will be seen as a rainbow. Okay, CNO. Example of refraction has sunlight rays bend through the only 10 minutes is left out. After that, we'll wind up the class. Bend through the raindrops. Bend through the raindrops, resulting in rainbow. Right? This is a third example of the real refraction of light in real life. Then the there's a second one. Third example, we can say that what's the thing? You all know about the prism, right? You all know about the prism. Do you know prism or not?
Yes, sir.
So say no. When the white light, if you're placing a prism somewhere else, like this, if you're placing a prism somewhere else, when the white light passes through the prism, when the white light passes through the prism, when the white light passes through prism, when the white light passes through prism, what will happen? Prism, then light has to split. It splits. It splits into what to say? Into what? Into different components of light. Different components of light means what? I'm talking about the VIBGYOR. That is VIBGYOR. Well, or else I'll write down the colors here: red, orange, yellow, green, blue, and violet. Why it is happening? It is mainly because of due to refraction of light. This is clear, ma?
Yes, sir.
So that is called as what? That is called as the. These are the three examples of refraction in the real life. First one is a mirage or the looming. That is an optical illusion which happens due to refraction of light. Then second one is what? Formation of rainbow. What happens in the rainbow? Whenever the sunlight rays falls upon the water droplet or raindrops, it bends in the raindrops and results in the rainbow. Then the third one is what? When the white light passes through a prism, then it gets splits into different components of the light. That is what VIBGYOR colors. All the VIBGYOR colors will be seen on the other side of the prism. Right? That is a refraction of light in real life. The next one we can see applications. These are the examples they might ask sometimes in questions. Some examples or applications of refraction we can expect sometimes in the exam also. Application of refraction of light. So now, first of all, this refraction has many applications. It has many applications in optics. Optics wherever we use different kinds of optics means many things. It comes like making of the cameras, is making manufacturing of the spectacles. Wherever the glass comes into picture, there it is used, and also in the technology. It has many applications in optics and also in the technology. Let us see now on some few of them. So CNO, mostly CNO. If anyone is aware, now take an example like a lens. Lens is an example of the refraction. Why it's an example of refraction? Because whenever image or object, whenever an object is placed before the lens, then the image of that particular object will be magnified. That is one example of a refraction. Lenses uses refraction. Lenses uses refraction to form an image of what, ma? Of object. Image of object. Like for various purpose, we can say. Well, we don't know where they use, but they get used for various purposes. So one example is such as magnification. Telescopes. We can call telescopes as one of the example. Telescopes. Then the second one we can say spectacles. Spectacles worn by people. The people use the spectacles, right? Different. The spectacles worn by people. Why do we wear the spectacles? Because of due to defective vision. Spectacles worn by people due to defective vision uses the principle of refraction. Even in the spectacles, there is a principle of refraction. The next one. Refraction, it is used in cameras. It is used in movie projectors. It is also used in, okay, anyway, one example I have given, telescopes. It is used in p-holes. P-holes of house doors. All these are the examples. Is there any doubt?
No, sir. No, sir.
No, sir. Sir.